trying to make this demo heavy, so you get to see it working more than me talking about it. Okay, so this is me. As Pepper said, I run Copperblue with Jen, and I do data and process integration. So I do things like Pig, Hive, SQOOP. I do Stream Insight, integration services, ZeroMQ, RabbitMQ, all of the message queuing in Azure as well. I try to get data talking to each other. I'm a SQL Server MVP, have been for a while, and that's my Twitter and that's my email. You can tweet me or email me after this, even if you can't think of a question whilst we're going through it, and write it down, or you maybe want to ask a big question, then by all means just email me and I'll try to answer it as soon as I can. Okay, so this is the agenda for today. We're going to look at what is SQOOP and why would I use it. We'll also look at when you would use it and how. So that's really the important part, and that encompasses the demos. And I've tried, like I said, I've tried to make this demo heavy. I've got quite a few demos. I was running through it yesterday. I've had to cut some out. I got over demo heavy, and I needed 2 hours just for the demos. So we won't be doing that, and we'll just run through it. The main aim of today, though, is to give you guys and girls an idea of what SQOOP is, why it may be useful for you. Not everybody's going to use SQOOP. And also have the ability to go back to work, maybe download one of the Hadoop distros, be it whatever, be it HD Insight emulator, be it on Azure, be it MapR, be it Cloudera, and just start to play it. Have the confidence to go start moving your data from SQL Server, Oracle, MySQL into Hadoop. Okay, so what's SQOOP? It's certainly not one of those. Although that is a SQOOP, that isn't the SQOOP that we're going to be talking about today. I think that's an ice cream SQOOP. So that is very definitely not what we're going to be talking about today. That was a little bit of humour. Usually I don't do humour in my slides. Sometimes it works and sometimes it doesn't. Okay, so what is SQOOP then? So SQOOP is SQL to Hadoop. And it's kind of a misnomer. Really, it should be something like reloop, because it's more about taking data from a relational database to Hadoop, but I'm not sure that's as catchy. But then with SQOOP, you see, you can go back from Hadoop to SQL, so then the name gets really stupid, so SQOOP and oops. So, and that really wouldn't catch on. Jen Stirrup, whenever I'm presenting with Jen, she always makes a comment that Microsoft spend a lot of time branding their products just right. So Windows, Azure, SQL database, so they've got all the naming just right. And it always amazes us how they've now got a Hadoop distribution with names like Pig and Grunt. And it must be difficult for their marketing team to get their head around these developer type names for some of their products, but I guess they're going to have to learn, because that's what everybody knows them as. Okay, so what does SQOOP do? Well, it does a whole load of things, to be honest, and it depends on how you're going to use it. So if we're coming from the relational database to Hadoop, what we can do is we can move your relational data and we can place it into files inside HDFS or HDFS. This would be useful if it can be useful if you're using Hive as well, but Hive you can load kind of directly. So files might be useful if you're going to then use Pig. So maybe you want to take your data, load it into Hadoop, and then use Pig to massage that data, join it with something else from somewhere else, use MapReduce to mash all that data together and put it somewhere. You can also load Hive, and for those people that don't know what Hive is like the data warehouse for Hadoop. It provides a structure over the top of HDFS files that allow you to issue things like select star from table limit 10, i.e. give me the top 10 rows of this table. What can we transfer? Well, we can transfer whole tables. That's really easy. We can transfer only certain attributes, and we can issue queries against our relational database to only take across a certain subset of data. If you go to the Apache website and look at the SQOOP page, you'll notice that there's a massive amount of optional parameters that you can specify, and some of them are very specific. So there's even specific ones for MySQL. If you're using MySQL, there's specific ones for MySQL. There's specific ones for HBase. Excuse me. So it does take a while to get down the page, and it does take a while to understand which ones you actually want to be looking at. But hopefully today we'll start with the ones that you're going to use most often, and then you can go read the documentation. It's not all that bad. What you can also do with SQOOP is you can load particular partitions in Hive as well. So just like we've got in SQL Server, in Hive you can create partitions of your data, which allows Hive to find that data more easily. And you can go and load particular partitions if you wish. So Hadoop to SQL, you can only take files. So you pick up the files and you move them to SQL Server, Oracle, or whatever you want. Depends on whether you're using those files as part of Hive, as part of the data for Hive, whether or not you would actually use SQOOP to take it back from Hadoop into SQL Server. You might just use integration services. And I'll show you a way that we can go to integration services and take data from Hadoop. Okay, so why SQOOP? And I guess that's a good question, because it's one of the things that I get asked, and there's a lot of people saying that we're trying to solve big data issues. We're trying to solve small data issues with big data solutions. We've got a perfectly good large SQL server, and it crunches data very well. Why do I need to do this? And that's a very good point. And I've got two use cases after this, because relational database systems are very good at storing data, and they're certainly very good at crunching data. But there are a couple of scenarios that we've seen that make storing your data in Hadoop viable, a reasonable choice to make. Okay, so the first case is one that we've actually just started. We've just started work on. Is a customer of ours has data in SQL Server, but they only hold essentially what is a hot subset. So they only hold 3 months worth of data, and that's it. It's a rolling 3 months. The rest of it is archived off, and that makes it extremely expensive to be able to query over large periods of time. So what they're doing is they're creating their data warehouse in Hadoop, and daily, nightly, they'll take their data that they want and push it into Hadoop. And the data warehouse then has the ability to query over time. And they're not incredibly large data sets, so they might be pushing 50 gigs worth of data into Hadoop every day. But as those years build on, that becomes a lot of data. The second use case is a paradigm called MapReduce. So what happens is people put their data from their relational databases into Hadoop, and they use MapReduce to crunch the data. Once MapReduce has done its thing and it's output some files, the results of these jobs or jobs, that data can then be taken back into the relational database. So a quick recap, what is Hadoop? Hadoop really is only two things, right? So it's a distributed file system and it's MapReduce. Most people, when they're talking about Hadoop, are talking about the Hadoop ecosystem, so Storm, Impala, Hive, Stinger, Pig, all of those things, those are the ecosystem, right? But Hadoop itself is a distributed file system and MapReduce. It scales to potentially thousands of nodes. It's meant to be run over commodity hardware, so you're not meant to buy the big boxes and keep plugging those in. You're meant to buy relatively cheap hardware, and it's meant to fail. And you just whip it out, plug it in, and into the fabric, and you've got another node, another node, another node. I think Facebook has got something like a 4,000 node cluster and more. And this is MapReduce. What MapReduce does is it takes an input query, composes that query over a number of nodes, so it maps it out into a number of nodes. They operate independently on their own independent copy of whatever data the query has been composed of, and I'll show you an example of that later. The results of those mapping exercises then get reduced into the output. So it comes down, it gets shuffled and sorted, gets reduced, and gets output. So instead of us issuing a query that drowns a single box, what we do is we compose the query, or MapReduce composes the query over potentially many nodes, and then reduces it down and gives you the output. Okay, so how do I use SQOOP? Well, you need a JDBC driver, and you can copy that to the bin folder of the SQOOP directory. And if you're using one of the other distributions, it's similar. You need to get the Linux version of the JDBC driver and copy it across to the SQOOP directory. There is no UI for this. I don't know that anybody's building one either, so everything is command line. You've got to have a lot of patience because sometimes you won't get the parameters correct, and all you'll get is a lot of Java error code that codes that you've got to run through, and you'll get logs. You've got to go and try and decipher what exactly it is that went wrong. So you've got to have a bit of patience, and like I said, there's no UI, which I guess is something that people who use Microsoft products expect. But it is powerful. Once you get around that, it's a powerful tool to use. Okay, so we've covered essentially the basics of what SQOOP is and why you might use it. We've seen two use cases, and they are valid use cases. But as I said, not everybody is going to need to use SQOOP, and if SQOOP isn't a tool that you want to use, that's fine. But at least, like I said, one of the things I want you to take away from this presentation is it is a tool, it is out there, and you can use it. Okay, so I'm going to cover a number of demos here, and let's do that now. Okay, let me oh, you can't see it. Right, good. Right, so I've got two windows up here. So although the primary ingredient of today is going to be SQOOP, what you're going to see is me using a little bit of Hive as well, because excuse me, Hive allows us to visualize what it is that I've just done. Another tool that I'm going to be using is this from Redgate, which is HDFS Explorer. It allows us to look in our HDFS directories just like it's a Windows directory. So that is incredibly useful, or it's been incredibly useful because I can delete folders, I can delete files and play around. Instead of using the Hadoop file system, Hadoop FS-put local file into the Hadoop HDFS file system. Okay, so let's get my windows back up again. And generally when I'm going to use SQOOP, the very first thing that I want to do is I want to connect to my data source and just have a look at the tables. So let me go ahead and do that. Okay, in fact I'll pull this over. And what we'll do is, okay, so we've got SQOOP. The command is to list the tables, and then I want it to connect to a JDBC connection string. My username is SQOOP, and capital P means ask me for the password. So I provide the password. And there you go. So now I can see the tables that I have in the Contoso database that's on my local SQL Server. So not particularly useful, but it allows me to go and just issue a query against the SQL Server. So remember that SQL Server could be anywhere, right? And this could be a Linux box. So I wouldn't necessarily have Enterprise Manager, that's something right. SQL Server Management Studio. Okay, so let's load up a Hive table. Let's put some data into HDFS. So what I want to do is I want to show you in Hive a table. So describe formatted Hive demo. Got here is you get useful information about the table, so you can see that there's 3 attributes, PK, BK and val, and you can see the location of the table, which is user demo tran table, or that's where the data will be, and it's an external table. An external table simply means that the only thing Hive's managing is the metadata. It's not managing the actual data. So if I dropped this table, it would just drop the metadata. The data would still exist, but the metadata for the table would still exist. And we can go do a select start from Hive demo. And we've got 4 rows in there. So user demo tran table. So what we should be able to do is go to user demo and tran table. Let's get rid of that. And we can now instantly go back here. You can see that we've got no data. So let's go ahead and let's reload that table. So we'll go to SQOOP again. Okay, so this time the command is that we want to import. We'll connect to the same SQL Server, pass the database, ask me for my password. The table that I'm going to come from is SQOOP base, and the target directory is user demo tran table, and we've got 1 mapper. So you'll see that you get lots of outputs on the command line. So it tells you exactly what it does. It tells you how much of the mappers have run, how much of the reduced jobs run, what the name of the job is, so that you can go into the website and search for that job and see what happened. So you get lots of information. It's just very, very textual. And you can also see the SQL statement that it's executing, and it'll go submit that job, and hopefully it should return some data. There we go. So if we look at the bottom, we'll see that it retrieved 3 rows. So now if we go back to Hive, we should see those in our table. Okay, so now that we've got that data into tran-table, the data's contained in that file there. If we delete that file, we effectively truncate the table. So what if we want to put some more data into that table, essentially? What if we wanted to load the next day's data? Well, there's a couple of ways that we can do it. So what if we had a different table which had the hot data for today's data that we wanted to import? So one of the ways that we could do that would be, just let me get it from my other window. Would be again to import. We'll take it from a table called SQOOP Daily this time. Same destination table, but it's important that we specify append at the end. If we don't specify append, what it will complain about is that that table already exists. You're trying to overwrite it, and you're not allowed to do that. So what I want to do here is I just want to append. So let's see that in action. So again, we get all the stuff about running a job and what SQL statements it's doing and which jar files it's created. So now we just have to wait. It's not. It might be a feature of my setup, but it is relatively quick to use. I mean, we were like I said, on this customer, we were transferring large amounts of data. I mean, it was relatively, excuse me, it was relatively quick. Okay, so down the bottom here, you'll see that it says appending to directory tran-table, and it retrieved one row. So let's see if it did. And it did, so number 4's in there, the PK of 4's in there. And what we should also see is if we refresh this, is that we'll see another file in there, which is number 1, and that should contain the data that we've just loaded. And there we go. That's the data that we just loaded. Okay, so that was an example of using it if we've got data in a different table. But what happens if the data exists in the same table? So how do we get the data, only the new data, out of that existing table? So let's go to SQL. Let's delete that for a start. So now we only have 3 rows. What we'll do is we'll go to SQL Server and we'll import into our base table the daily data. So if we now look at SQOOP Base, we've got all 4 rows in there, but the only row that we actually want to import is number 4. So like I said, there's a number of ways that we could go ahead and import that. Okay, so the first way that I want to show you is that we can do an incremental append. And this is the way that we might do that. So again, we're importing, connecting to the same database, the username, the table. The target directory is the same. The incremental value is to append. The column that we've got to check is the PK column, and the last value that we saw in there was number 3. So let's go ahead and do that. So one of the interesting things that you'll see there is that it knows that the lower bound value is 3 and it knows that the upper bound value is 4 because it's issued a select max PK from SQOOP base. Okay, so it's going to run that job. And what we should find now is that it puts that single row file back again. There you go. So now if we go back to our directory, refresh, we should see part 1 and in Hive, we should see 4 rows. Okay, so another way of doing that is to use the where parameter. So let me show that. Just move it over there. So what we can do is we can specify SQOOP base as the table, and then we can specify where, and we can say if PK is greater than 3. So that should have the exact same effect. So just leave that to do that, and if we go back in here we should see the single row, and again it's a single row file. Hive says we've now got 4 rows, so all's good. So another way that we can do it is, and I'm not going to, what I'll do is I'll drag it over my demos here and I'll just highlight one of them. I won't show you another way of doing that exact same thing, but this is one that caught me out. So the thing that we're looking at here is this, right? So we're connecting and then we're passing it in, but what we're doing is we're passing a query this time, and you'll notice that $conditions. Now that $conditions has to be there. So even if you've got no where clause of your own, you have to put where conditions, right? But that's not for you, that's for Hadoop. So what Hadoop does with the where conditions is it says, you know what, this is my opportunity to compose this query across multiple mappers. So if you specified 3 mappers, 4 mappers, it gives Hadoop the ability to say, okay, I'm going to place my own conditions after your where PK is greater than 3. Yeah. So how can I best show that? So what we'll do is we'll do this. What I'll do is I'll get rid of tran table. So I've effectively just truncated it. I will paste this, and you'll see that what I've got here is I've got where primary key is greater than 0 and conditions. What I've also got is I've got 2 mappers, or I've asked for 2 mappers, and I say you can split the query, i.e. compose the query by PK and append. So let's have a look. What I've also got here is I've also got profiler running, so you can see what happens against SQL Server. So I should be able now to say, okay, go ahead. And what it's going to go do now is it will look for my greater than 0, but what it will do is it will take the data that's greater than 0 and it will create its own SQL statement. So it will create multiple threads going against SQL Server and issuing individual queries that can then be mapped. So you can see it's doing a little bit extra. Okay, so it transferred 4 rows, but what did that look like to SQL Server? Well, if we come down to the bottom, what we should be able to do is, let me take the first one obviously. So if you look, you'll see this is what Hadoop actually issued. So we've got where PK is greater than 0, that was the bit that I did, and then it says, okay, where PK is greater than or equal to 1, and PK is less than 3. Because then, separately, it says, okay, now do PK is greater than or equal to 3, and PK is less than or equal to 4, because it issued a bounding query initially, select min and max, so it knew the bounds, and it knew that I wanted 2 mappers, and it then distributed those PK values, because that's the split by column, and it distributed them across multiple threads so it could do multiple mappers. So that's the where conditions, and I think that's a good example of that. And with multiple mappers involved, we should get multiple files having been created. So we should be able to go ahead, and there you go. So this file should contain 2 rows, and this file should contain 2 rows. Okay, let me get my demos back over this side. Okay, so let me now go back to my, let me see if I've got anything in this table. Good. Let's get rid of that. Okay, so we've just truncated that table. There's nothing in there. So we've all had this problem before in SQL Server, right? I defy anybody to tell me that they haven't had this problem before. When they're using integration services and they've exported some data and they've got all the delimiters wrong and everything's going slightly nuts. So what we can do is we can drop the table Hive string demo. So let me do that. And we've dropped that table, and then what I can go ahead is and import some data. So slightly different. This time I'm coming from a different table. So I'm coming from bad string data, and the target directory is demo bad string data. So if we go and have a look from that, so see what's in that. This is an easy piece of text. Okay, so that's absolutely fine. Let's go and import that. Okay, it's still working, pushing the data in. There you go, it's retrieved the record, and we should get our data. And now what I can do is I can go create a table over the top of that. So in Hive, I can just create a table, And we're going to create a very simple table. Row format's delimited, fields terminated by a comma, and the location is user demo bad string data. And what we can do there we go. Put the name of the directory. So a Hive string demo, this is an easy piece of text. So what happens then if we do this? So we insert a piece of a chunk of data that has a comma. So if we go back to our bad string data, so we can just delete that again. Now what we can do is we can re-import it. So I think for one of the engagements that we've been on for this particular exercise, it was a case of they didn't actually know what delimiter to put, so we had to do this exercise for a while because they were encrypting some of their data or obfuscating some of their data within the attribute. Finding that delimiter wasn't actually all that easy. So let's go ahead and look at, so let's start from Hive string demo, and as you can see, I'm sure we've all done integration services, this is A. So we've completely missed off the end of the text because it thought it was a new attribute. So how do we solve it? Well, it's quite simple. So what we'll do is we'll get rid of bad string demo. What we have to do is we will recreate our table, but this time we'll delimit it by a pipe. And then we just simply need to re-import and you'll see fields terminated by pipe at the end on my command line there. So let's go ahead and let's insert that. File already exists, so that's what we were saying before. So if we do bad string data, so now it should import that data and it will put a pipe between the attributes, which should then allow our new table, which has been defined with field delimiters of pipe, to read the table correctly. So there you go, it's retrieved 2 rows, and then this table, so this table should be select start from Hive string demo. And there you go. You can see that now we have that comma in there just fine. Okay, so let's have a look at loading some data into Hive partitions then. I've got a table called charge in Hive. And what I'm going to do is I'm just off to ask for 10 rows. And what this is just a few rows of data with a date and some attributes that like membership number, customer number, etc. with a value. Okay, so what I want to do is I want to create a table that will partition that data. So I need to issue a query against Hive. So drop table police partitioned, create table police partitioned, reported by falsely in longitude, latitude, and it's partitioned by crime type. So what I did is I actually showed you the wrong table up there. So what I'll do is after this has been created, I'll show you the correct table that's going to load this. So let me go ahead and create that. And then what we can do is we can describe formatted police partitioned. If I could spell. So there you go. So you'll see that there's the attributes that were specified. Here's the partitioning information. Managed table means that Hive manages it, and this is where it manages to hold that data as well. So let me just show you the data that we're going to load from, that has been loaded. It's select star from police non-partition limit 10. So there you go. So this is data for Kent Police, which is where I live in the UK. This is the lat long of where it happened. This is the description. This is the crime type. Now the idea is that we want to load using SQOOP into Hive partitions. So how do we do that? Well, turns out it's quite easy. So all of this data, all of this altogether data is here. So this is what I want to load. So you can see that I've gone against the table altogether. I've issued a where clause, which is where crime type is equal to burglary. It's a Hive import. The Hive table is police partition. One mapper. The partition key is crime type. And the value is burglary. Okay, so let's go ahead and do this. So you see that we've got excuse me, police partition there. You see that it's finished, and you can see that it's done that. So what does that look like in here? Well, this is what it looks like. Crime type is burglary, and there's the file. And if we had multiple partitions, then it would be crime type is equal to something else, crime type is equal to something else. And if you've got multiple attributes that you have as your partitioning key, it would be crime type is equal to burglary maybe, then it would be location is equal to X, and then it would be something else, and something else. And you can have quite a deep nested partitioning scheme. So the final demo that I want to show you is, remember I said that a lot of times if you're going from SQL into Hadoop, we can also go from Hadoop into SQL Server. And this might be the result of your Hive jobs, your MapReduce jobs that you've been doing, or your pig jobs, and it's deposited some files, and now what we want to do is we want to go load that back into SQL Server. So let me just go make sure that there's nothing in people data. Right, so there's nothing in people data. People data, though, looks like this. This is what's been loaded into Hadoop. I've just got a data generator off the internet, and it generated 100 rows. Yes, it's limited by pipe. So now what we want to do is we want to take this and put it into SQL Server. And the way that we do that is this. So you can see that we're taking people data, where export directory is SQOOP export, so that's where the file is. So you can have a look at SQOOP export, and that's the file. And I've specified what format it's in, so you saw that they were pipes and my new line. So let's go ahead and let's push those rows into SQL Server. You can see the total input paths to process there. That's basically how many files has it found in that directory that it needs to push into the destination. So there was only one file, but obviously, if there's 2, 3, 4 files, then that would be 2, 3, or 4 input paths. Okay, so it's exported 100 rows, and hopefully if we go back to SQL Server, and there we go. Just one last thing. Like I said, if I was coming from a Hive table and I was going to SQL Server, chances are I'd use integration services. So here I've got integration services. I just drop on an ODBC source. I'd use the Hive ODBC. And then, as you can see, I've got my pick of tables in Hive to move. So that's how I would do it. Integration services like this doesn't push into Hadoop. So you can't take data and push into a Hive table. You can try, but you'll get errors that the syntax that you tried to use isn't correct because it tries to create a table. So it just won't be correct. Okay, so that's all of my demos. I don't know if I've got an end slide. Okay, I do. And that, like I said, that's me, Twitter and my email. So if you have any questions that might be a bit longer than you want to write in the chat thing at the side there, by all means, let me know. Contact me on Twitter. Yeah, and hopefully that's given you some food for thought. Hopefully now you know more about SQOOP. Thank you very much.
Thank you, Alan. That was a great session. We got a couple questions here. The first one is SQOOP more robust than Microsoft Polybase? You can read them in the...
Is SQOOP more what, sorry?
You can read it on the question section in your GoToWebinar window. And the question is SQOOP more robust than Polybase?
Oh, so Polybase, so Polybase just goes, as far as I can tell, Polybase just goes against a Hive structure that's in Hadoop. And when you issue a query, the optimizer knows which path to follow. So it knows which tables are in Hadoop and which parts to pass off and which parts are in PDW. Is it more robust? I don't think that's necessarily the case. So if you bought PDW, then you bought a big lump of metal. SQOOP would still be able to push your data from other relational data sources into Hadoop, but you could do that through PDW as well. So I think whatever you're happiest with. I guess it depends. If you're coming from Unix, Oracle Unix, Polybase isn't going to help you because you're not on the SQL Server. So SQOOP is still valid in a lot of scenarios.
Okay. What is the purpose of partitioning tables or files in Hadoop as you demo using SQOOP? Is it for performance or other management reasons?
Yes.
Okay.
Yeah, so you can. So it's for Hadoop. It's for Hadoop to be able to find your data. So it's very, very similar to what SQL Server uses partitioning for. You can create manual partitions. So you can create. So you saw there that I'd got one called burglary. I could create my own partition, load some data through another process, and then add that partition to the definition of the table. Yeah, so I could just bolt on another one, I could take it away. So in terms of management, I personally think that managing partitions in Hadoop is probably easier than it is in SQL Server.
Great. What configurations we have to make in order to see Hive tables in an SSIS package?
You don't. So there's a Hive driver. So if you can use the Hortonworks one. So if you go to Hortonworks, you can download their Hive driver, and it works against HD Insight. And you get a drop down for which version of Hadoop you want to go to. So if you want to go against the one in Azure, do you want to go against the emulator, do you want to go against HDP, and it'll configure the ports for you. You just got to provide the server name, and just in case you have changed the port, you'll do a port, and you'll provide any authentication that you need. But Hive, it just hooks up to Hive based on. So Hive, really, if you didn't tell anybody, they'd never know any different. They'd never know that they were going against Hadoop. So there's no configuration changes that you need to make.
Okay. Do you have any load times? I would say he's asking about the stats.
Yeah, so it's really going to be, a lot of it's going to be on how beefy are the nodes in your cluster. So the thing about Hadoop is for people who expect sub-millisecond performance, Hadoop probably isn't going to do that. There's the Stinger initiative for Hive, which tries to subvert MapReduce, but you're not going to get that level of performance. Where Hadoop gets the performance is that it allows you to compose the query over many, many nodes, and it allows you to crunch huge amounts of data more efficiently. So we were loading. I guess we were loading into over the network. We were recently loading 500 million rows per night, and it was taking us 1 hour 50, 1 hour 55. That type of time, which I don't know, is that fast? Is that slow? I mean, this was a 6-node cluster with each node had 24 gigs of RAM, it had 1.5 terabytes of disk. It was a 2-socket, 8-core box on each of the nodes. It was perfectly fine for what they wanted to do. I mean, I guess it depends on what you call fast.
Okay, if you're loading SQL Server from Hadoop, when would you use SQOOP over SSIS? What is the benefit?
So what would be the benefit? The benefit would be that if you haven't created a Hive table over the top of the data, then you could use SQOOP to push it into SQL Server. If you have, like I said, what I would probably do is I would probably use Hive in SSIS. Why? Hive was written because Hive and Pig were written because the people who were using it, Facebook and Yahoo at the time, hated having to write MapReduce jobs all the time. So what they created was Hive and Pig, which essentially issue the query, but that they generate MapReduce jobs behind the scenes for you, so you don't have to. So if I had a table in Hive, I would definitely be using integration services to get it out again. Simply because I've then got a tool I can build a workflow around, right? So integration services, I can build a workflow. I'm happy with it. Whereas SQOOP, it's on the command line. Sure, you can call it on the command line, you can do all that. But for integration, nice to just use one tool.
Great. We got Tim Roberts who did ask, do you have any load times? Now he's asking, and was that 500 billion or 500 million overnight, 8 hours?
No, so that 500 million was it was after work, yes. So it wasn't during the day, but it took just short of, let's call it 2 hours.
Great. And that was SQL to Hive or Hive to SQL?
That was going from SQL Server to Hadoop. So what happened was we pushed the data in using SQOOP. We then ran some pig jobs over the top of that data once we got it in, and then Hive would sit on top of the results of that cleansing.
Okay, I think that is pretty much all the questions. Well, thank you, Allan, for the session and for answering the questions.
Thank you very much for inviting me to speak.
Great. Okay, we'll see you at next session. I have not announced it yet because the speaker still gotta confirm the date, but it's gonna be about SQL Server 2014 and big data, and it will be a Microsoft speaker. So keep checking the website. I will also email you to announce the session, and within the coming days you will have this session recording on the website in case you want to share it with any of your colleagues. It will be in YouTube. I have a link to the YouTube Big Data Virtual Chapter channel. Okay, thank you very much. Cheers.
Thank you.
Thank you, Allan.